Now we're going to try and do the selection of attributes by using wrappers. So we are going to begin by setting a set, 1, 2, 3, and I am going to follow a random process by using the wrappers. The wrappers are also explore solutions with a certain level of randomness with the initial values that are explored, or even in the further steps. Um, there are solutions for attributes that have more potential. So the first thing that has to be done in the wrapper is to do the evaluador. This is the model that we're going to use. That's the main characteristics of the wrappers as we saw in the presentation. That the learning algorithm is used here. So in this case, we're working with KNN, so the selection can be different when we use KNN or when we use random forest or vector machine. They can vary. The best solutions can vary because it depends specifically on the method. The second thing we assess is the searching criterion that we're going to use. So we can specify it here with the search algorithm that's an FSN package, and we can explore here the possibilities that are available. So in the search, with that criterion search, we can see that there are several. We have ant colony, we have genetic algorithm. This is one of the simplest one. It's called hill climbing. Las Vegas, that includes the sequentials, um, floating forward, floating backward. So there are different options. Some of them are slower than others. So you can test several. In this case, and for this exercise, I'm going to use this one. That's the simpler one. That's called hill climbing. And they also include default parameters. So if you want to dive in a little bit more, you can explore in the help. And I was looking a little bit more for the stop criterion, but I didn't find too much information within the algorithms. It's something that has to be established. They say that solutions are tried until they don't reach a significant improvement. That's the automated criterion that's included by default. So I'm going to execute these lines here. The evaluator or evaluador. And now we execute it with results. I'm going to use these function that's called feature selection. And I'm going to tell what's the data, what's the response variable in this database. And what's the search criterion and my evaluator. So I'm going to leave it here. Apparently I made a mistake here. I was putting it here in English and it was in Spanish. Evaluador. Sometimes my English and Spanish get all mixed up, but you can organize your scripts in a better way. The method might take a little bit longer. This is one of the things to take into account between filters and wrappers. You'll realize that the wrappers are slower, and especially due to this condition, because each one of the solutions that they're going to explore are going to identify the results that have the most potential, but based on the execution of the algorithm. That's KNN in this case. If it was a heavier algorithm, it'll probably take a lot more time than now. So we are going to wait for a little while longer. And there you go. Finally, it finished. So now we can assess the results. This gives us general information about the model. We can see that it took a long time. The best value is 6.74. Now we'll make sure it's this value with the train model. And these are the variables that were selected during the search. So 0 means that it's not a relevant value, a variable, I'm sorry. Remember that filter also included this one, is one of the last ones. And it shows me the other subsets also. So what I'm going to do now is to try and choose the variables that were chosen by the wrapper, and I'll train the model once again based on this wrapper. So to do this, I'm going to use one of the R functions here. Let's select vars, and I am going to tell it that I want to know with that result vector the results which are equal to 1. So I'm going to extract these positions only. I was missing something here. I have to extract out of the list with the best features. Select bar. So these are the positions. With the positions already, I can train my model once again. I'm going to copy it again. I'm going to take the lazy path. I'm going to copy the same model that I use for filters here, but I'm going to change it with a new selection. So I'm going to write here wrappers. And I'm going to indicate that the selection for variables, before this it was by name, I think. I'm going to do it by numbers now. So I'm going to keep this vector here, but I'm going to say that these are the positions. And I am also going to say that since I'm putting positions, the yield was in number 26. The same here, nothing changes here. The same method, KNN, tune length, and I'm going to add here the set dot seed in order to have the same possibility that the other models, so they can be reproduced. And I'm going to execute it once again. And let's check the results. There you go. Before we used to have an RMSE that was a little bit over 7. Now we can see that with the wrappers, we were able to reduce it. So they improve. They improve as when we use our complete data set, then with filters, we eliminate some variables, and now we reach an optimum point of 6.85. The next would be to test it with one of the algorithms that are embedded.